All right, we're going to go ahead and jump back into the review here. And we got through tomorrow to get the rest of it done. So, I believe we left off at number 28. So we're going to finish up some function stuff, and then we'll go into like some more of like the trigonometry stuff. We got a few more pages of like function stuff, which has been a while. So some of these are rather easy, some not so much. But at any rate, the actual exam, like I said before, is not this long. It may not even have everything that's in this. But it will cover at least everything. Oh, yeah.
Just one question.
What's that?
The exam you want.
I don't think you would want that because then if you miss it, then you get a 0%.
Just make it very easy.
Yeah.
Oh, I forget.
No, it's
Is it missed?
All right, so let's choose which one of these is written in standard form. Pretty easy one here. So it's going to be C. Highest power, lowest power. All right, a few terms. This is more so so when we answer harder questions, you remember what all these things are. The degree. What is the degree of this polynomial? 4, yeah. Degree is the highest power. If we're to write this in standard form, that just means basically put the highest power to lowest power. It's just going to be f of x equals 4x to the 4th plus 5x squared. And then the leading term is just going to be the entire term that's first here, 4x to the 4th. And the constant term, any constants there? Oh, all right, next we're going to talk about zeros and multiplicity. So if you remember, like multiplicity told you like if it touched across the axis. Anyhow, this is in factored form here, and we're supposed to find the zeros and then list their multiplicity. So since it's factored, you're just going to be setting each of the factors equal to 0. This one, and you can probably do without even setting equal to 0. Set x plus 4 equal to 0. Set x equals -4. That has a multiplicity of 1. And then this one could be x equals -3 to solve it. And then its multiplicity is 3 because the power out there is the third power. So the multiplicity is how many times it's repeated. This root is repeated 3 times, so its multiplicity is 3. You may not remember this one, max number of turning points. Anybody remember how you find that? Yeah? Yeah, it was 1 less than the degree. So the max number was this little equation n minus 1, where n is the degree of the polynomial. So what is the degree of this polynomial? So when you multiply this all out, you would end up, this is x to the 3rd. You would have an x here, and then you have like the 4. So the leading term would actually be 4x to the 4th. If you were to multiply that all out, you don't have to actually do that, but if you just do all the first terms, so the degree is 4. So it would be 4 minus 1. So a maximum of 3 turning points. A lot of this stuff isn't hard, but you might have to jog your memory to get it back there. All right, and then let's just do one of these equations here. We're supposed to write a polynomial that has roots of x equals 2, -3, 5, and then they're given multiplicity. So it'll just look like this. F of x is the root of 2 means we write this as x minus 2 in parentheses. And then the multiplicity of 4 is you do it to the 4th power. We have x equals -3, it'll become x plus 3. Multiplicity of 2. and x equals 5 would be x minus 5. Well, the multiplicity of 1, so there's no to the right. So you can obviously do 32 on your own. It's almost the same. 33 should be pretty easy to pick it out as well. 0 of 4 is the multiplicity of 3. Which one would that be? B, C, or D? It would be D. D has a multiplicity of 4, or 0 of 4. Right? Because you saw with x equals 4 and then the multiplicity of 3. All right, now in behavior, this might take a little bit of thinking about what happens here. So in behavior is how we have this set up as x goes to something, y, or we said something f of x goes to something. So how we determine the end behavior is we look at the leading term, which would be this one in this case, well, highest power. And so we're going to look specifically at the exponent. That's an odd exponent. And then also the sign there. That's a negative and an odd. And we have like 4 different possibilities for the end behavior. So with end behavior, you could have like an even positive. And then you can have like 3x to the 4th, like that. So there's even power and a positive lead coefficient. That looks something like this. So both go up that way. You could have an even negative, maybe like negative 3x to the 4th. And both will go down, switch down. You could have an odd positive. So odd positive would be something like 3x to the 3rd. Looks like this. Or you could have an odd negative, like negative 3x to the 3rd. Like that. Those are like your 4 possibilities for end behavior. You don't necessarily have to memorize the chart, but think about what's happening. If it's even, they go the same direction. Even positive goes to positive. Even negative goes to negative. They go opposite directions. If it's odd and positive, positive is positive, negative, negative, and then it flips. So in this case, we've got a negative and an odd. So it means this one. So it says x goes to positive infinity. Means as you like move this way, it goes to the right. Function goes down to negative. And then as you move to the left, negative infinity. If we go that way, function goes up to positive. So that would be it. And you can probably figure it out 35 there. So you want to look at this power and then look at the sign of the one in front. So the power is whether it's even or odd, and then the number in front is whether it's positive or negative. Go ahead and flip the page. All right, and we're actually going to do 37A first, and then we'll go back up to 36. Okay. 37A there. So we're supposed to determine if this is a factor of this one. Is it a factor? So we're supposed to do it using synthetic division. In synthetic division, that's where we write out these numbers and we make a box. Looks like this: 5, 4, negative 20, negative 16. Draw the box around it. And then what number goes on the outside? It'll be negative 2. It's always like if you were to set that equal to 0 and solve it. So it turns the opposite. We then bring down the first number, 5. We multiply. Negative 2 times 5 is negative 10. We add them up. 6. Multiply there. 12. Add them, you get negative 8. multiply positive 16, add them, we get 0. So is that a factor? Yes. Yeah. Because this is the remainder. If the remainder is 0, that means yes, it's a factor. So 36 is very similar, just that you don't have to determine it's a factor now, you're just going to divide using synthetic division. But the thing you have to watch out for is notice there's no third or fourth power. So it's kind of like 0x to the fourth, 0x to the third there. So remember when you do this, you have to put some placeholders in. So we got like 4, 0, 0, -2, 1, -1. And the same would be true for these two.
Teachers, pardon the interruption, but all Fire 1 students who did not get their picture taken this morning, could you please go and get them taken now? And construction technology, if you're able to go now, please go now. Thank you so much.
And then the number on the outside will be -2. So then we'll bring us down 4. This one's not really a great answer, but -8, 16, -32, 64. I don't know what 32, I did the math already. Alright, 16, sorry. -32. Add those together is
Also, electricity juniors, would you please go get your pictures taken in the media center also? Thank you.
and then we multiply those two. -2 times 4 is 68. Add them to get 69. Multiply those. So -1, 38. And so not the prettiest equation. And then when you divide, you're supposed to write the new function. You don't actually have to do this on the exam, but just review how to do that. It would hurt to get it out. You guys remember what power we start with here? Like 4. Yeah. Start with 1 less than what is given. So 4x to the fourth minus 8x to the third plus 16x squared plus 34x plus 69 minus 139 over. This is the remainder. Put it over the original minus 1. Mostly know how to do it to determine if it's a factor or not. You can try those other two on your own. Just again, don't forget there's placeholders. So like this one has a placeholder at 0x to the third, 0x. Don't forget those. And the one above it has a lot of placeholders. Okay, the next two are kind of a pair use the same theorem. 38, it doesn't actually say to use this theorem. So let's do 39 first and then we'll flip back to 38. So there now we're supposed to use the rational zero theorem, the rational root theorem. Anybody remember how to do this? So what you want to do is we're going to list all the possible rational zeros. We're going to look at the constant and leading coefficient. So we'll take the constant and we're going to list the factors of that. The only factors are 1 and 2, right? And the only factors of 3 are 1 and 3. So list the factors. And then the possible zeros are all of these over each other with a plus or minus. It's like a plus or minus p over q, if you remember that. And this is our p and that's our q. So it's plus or minus 1 over 1, plus or minus 1 over 3. plus or minus 2 over 1, plus or minus 3 over 3. So 1 over 1 becomes 1, then plus or minus 1 over 3, plus or minus 2 over 1, 2, and plus or minus 3 over 3. And then you use the same theorem to answer 38, where you have to determine which could not be a 0. So you list out the possibilities, and I think it becomes pretty obvious in 38 which one can't be, because you got to do that factors of 6 over the factors of 3. Try that one. Next page, this is our called the asymptote page, because that's what it's all about, vertical and horizontal asymptotes. So for the vertical asymptote, let's first just like define how you would find that. A vertical asymptote is a 0 of the denominator, but it has to also not be a 0 of the numerator. So it says the zeros of the denominator that are not also zeros of numerator. And then we also have holes as well. A hole happens when it's a 0 of both, and then like this stuff. So a hole is a 0 of both numerator and denominator. And then two just cancels out. So if we look at number 40, vertical asymptote there, we're going to find the zeros of the denominator. So we're going to set 5x minus 3 equal to 0. Add the 2 and divide by 5. You get x equals to 5. And then we just need to double check it's not also a 0 of the numerator, which is not. The only, so the numerator there would be like negative 4. So we're good. This is a vertical asymptote. There are some harder ones. We actually had like a quiz, if you remember, where you had to find all the asymptotes and intercepts, and then add the graphs up there, and you had to sketch a graph. So it's kind of that, except you don't have to do all the stuff. But on, let's look at number 42. In order to do those problems, you also had to factor them, which you do have to do here. It's not like they're super hard factoring, just really base level factoring for these. But you need to make sure you know how to do that. So with this first one, we're going to factor this top because it's 3 terms. We're going to factor into something in the parentheses there, next and next. We have to think what multiplies to give you negative 12 and adds to give you 1. So multiplies to give you the C and adds to give you the B. And those two numbers are 4 and 3, plus 4, minus 3. So multiply to give you negative 12, and then add to give you 1. And then we do the same with the bottom. We have to think about multiplies to give us negative 6, and adds to give you negative 1. Only one option there would be 2 and 3, so we'll get 1. So plus 2 and minus 3. And you'll see you got the same thing on the top and the bottom, which means that does cancel out, so that's a whole. The other one that's left here, this is a vertical asymptote, not a 0 numerator. So we said we have a vertical asymptote, and that's going to be an x value. You're going to write it as x equals negative 2. And then the whole is the one that canceled. That's going to write that as next value, x equals 3. So the wholes cancel, vertical asymptote is just 0 at the denominator. And you can do 41 and 43 on your own. I'll have the answers tomorrow. You can check them out. And then we'll move on to horizontal asymptotes. All right, so this one also has a few rules. Anybody know what the horizontal asymptote for 44 is? Or how we find it? So for horizontal asymptotes, we're going to look at the powers on the top and the bottom. So with this one, notice how the power is the same. It's an x to the first power and x to the first power on the top and the bottom. So in this particular one, where the powers are the same, we write out our rules here. So the degrees are the same. Degrees are equal. Meaning the biggest power on the top and the biggest power on the bottom are equal. And the answer is the ratio of these numbers in front. So if that's true, then it's the ratio, say y equals ratio of the lead coefficients. So in this case, it's going to be y equals 4/2, just 2. And it's a y value because it goes horizontally. The next one has our next scenario, which is that the bigger power's on the bottom. Like this doesn't even have an x. This one has up to an x cubed. So the degree is bigger in the denominator. Denominator. That's the larger degree. We don't even know what that one is. The bigger power's on the bottom. Huh? You're close. It's 0. 0, so it's y equals 0. Always going to be y. That would be the case with this one. Because we have x times x squared, gives you x cubed, and the top there's nothing. The last scenario, we don't have an example of it, but we're going to write it out. And that is if the numerator has a larger degree, in other words, the bigger power's on top. Then it actually is none. There's none, no horizontal asymptote. The numerator's bigger. There was actually a way that we said that, like if it's bigger by 1, there's a slant asymptote. It's bigger by 2 or more, there's nothing. But right now, just note that there's not a horizontal asymptote if it's bigger. Okay. So that's asymptotes. All right, now we're going to kind of move on to some trig stuff. A little bit more recent. That function stuff probably seems a long way away. So first thing is these conversions. And if you look at your reference sheet, I did put those are on there. So, remember, you'll get this. This one with your exam. And it has these degrees to radians, radians to degrees. It's just going to be either multiplying by 180 over pi or pi over 180. And it becomes pretty obvious which is the right one if you try it. Like, for instance, if you try, remember this is 7 pi over 12. If you were to do the wrong one, if you were to multiply by pi over 180, It's not really going to look right. So you'll have pi times pi, which would be pi squared. And it's not going to be a degree, so it'll just tell you got it switched. So it's times 180 over pi. The pi's then cancel. We should. And then we're just going to be multiplying straight across. We're just going to do 7 times 180, which is 1260. 12. With an erase.
Huh?
You guys an erase?
Maybe.
Fast walking race. Sweet walking. Alright, and that's 105. So same, the opposite, you're just going to multiply by the opposite thing. Negative 130 times, in this case we're going to flip it, so it's times pi over 180. And when you did this one, you shouldn't get like a decimal or anything. It should be just written as like negative 130 pi over 180, and then you want to reduce the fraction. But you can, if you're not great at it, you can always just type it in your calculator, like 130 divided by 180, and then you can always hit math and then frac. We'll give you there 13 over 18. This is 13, negative 13 pi over 18. And then we got some unit circle values. So just a refresher on how to read that. Again, it will be given to you. You don't have to have it memorized still. But hopefully you got some good knowledge of it since you didn't memorize it. You're going to just be looking up these values. You also have what they are down here. So for instance, we're asked to find the sine of pi over 6. Sine is y. So we go pi over 6, and we want the y coordinate, which is a half. Answer. For tangent of 3 pi over 4, if you don't know tangent, you look it up. It's y over x. 3 pi over 4 is right here. So y is radical 2 over 2, and x is negative radical 2 over 2. So this is going to be radical 2 over 2 over negative radical 2 over 2. And we have the same thing over itself, so it's just 1, right? Same thing over itself. So negative 1. If you keep change flip, you'll see they do cancel. All right, and then like cosecant, so you don't know what cosecant is, you can look at this. Cosecant is 1 over sine, which is 1 over the y. So we want to find the y coordinate at pi over 4, which is radical 2 over 2. 1 over radical 2 over 2. This one we do need to keep change flip, so we'll keep the top. Change it to multiplication and flip it. 2 over radical 2. This becomes 2 over radical 2. And then we need to rationalize that, so we're going to multiply by radical 2 over radical 2. And then we get 2 radical 2 on top, and 2 on the bottom. 2's then cancel, so we just get radical 2. And last one here, sine of the negative 3 pi over 4. So remember, negative is backwards. So negative 3/4 would be right here. This one, the sign is going to be negative radical 2 over 2. So that's that. And then we get into what we actually did pretty recently here. Our last quiz was on this. Amplitude period, all that stuff. So amplitude, always the number in front, right? Is it negative 4 or positive 4? Positive, yep. Amplitude's always positive. The period is what here? What's that? Close. You do use 3 in it. Yeah, 2 pi over 3. So it's the period is always 2 pi over the b. This is like our a. This is our b. Here's a c and here's a d. It's always 2 pi over b. And then the phase shift is the left and right. So that's inside here. So remember, it's opposite. So it's actually pi over 2. And then the vertical shift is outside here. It's 3. And you can do that one on your own for practice. This one, although the 2 now looks inside and this one was outside, this is still your B here. It's just this one's been factored out since it has that phase shift there. Put that one on your own. Okay. Well, let's just do a little bit more. Finish up with this. All right, 59. There should be actually an extra parenthesis here. Oh, I got it lost. Let's try to do the period on this one. So this is our B. So the period is 2 pi over 3/4. We do need that keep change flipped. So we'll keep 2 pi, change the location, and flip it. Negative 8 pi over 2.